So thank you for that introduction. As she said, I'm joined by the amazing Tim Bauguess?
Bogus.
No, it's Bauguess, right? And our presentation builds upon Donovan Brown's amazing keynote. We want to connect how modern DevOps impacts the quality of your software.
What is high quality software? Why is it important? High quality software is software that is made correctly throughout every step of the development process. High quality is critical for the success of software. End users benefit from being able to reliably experience the finished software as it is intended. Development benefits by having high quality software that is much easier to work with, and stakeholders benefit from having satisfied end users and increased development productivity. The stakeholders will receive the highest possible value from their resources. So how do you define software made correctly? How do you define software quality? Software quality can be broken down into models that cover two main categorizations of quality: functional and structural quality.
So structural quality is the component of software quality that focuses on non-functional requirements. This is the quality of how the software code itself is structured. Like efficiency, how does it perform? Is it responsive and stable under different workloads and environments? Maintainability, is it easy to keep the software up to date and implement new changes? Scalability, how well is potential growth of the software's user base supported? Security, does it meet security standards? Testability, how well does the software's design support being tested? And the functional quality, this component of software quality focuses on how well the functional requirements or features of the software intends to deliver to its end users are met. So like specifications, does it meet the specifications as required by the stakeholders and end users? It also must be reliable with few defects and not be seen as buggy. Zero defects is probably impossible, but you can still have high quality software with minor defects. And usability. Does it respond correctly to various input, and do users have a positive experience?
So how do we ensure high functional and structural quality in our software? Start by focusing on process quality. I understand. Process quality can be easily overlooked. It can be hard to see the immediate benefits of improving your development processes. What have you been doing works, so why bother? Why take the time now for unknown benefits? The benefits are not unknown. Yesterday you saw Donovan Brown's videos on how pit stop efficiency is improved from a minute to seconds. Even after getting it down to seconds, did they stop improving? No. They continuously monitored their pit stop processes to find more ways to improve. So process quality can be broken down to just one thing: constant improvement, maximizing your value. So analyze your own development processes. Where can you improve? Start incorporating more of these modern processes. Donovan Brown shared with us about how Microsoft began prioritizing their process quality by incorporating Agile methodologies. You can too. You do not have to do it identical to Microsoft. Feel free to adjust the industry best practices to create a process that works perfectly for your environment, as long as you keep the right mentality. Individuals and interaction over processes and tools. Working software over comprehensive documentation. Customer collaboration over contract negotiation. Responding to change over following a plan. Does this sound familiar? This is the Agile Manifesto. So how do I get started improving my processes? How do I ensure high structural and functional quality in my software? By moving forward and integrating modern, agile testing practices into my development process.
So development teams should take advantage of modern testing practices to ensure high software quality. Agile software development processes involve an iterative and incremental approach to software development where your teams are able to respond better to unpredictability and deliver higher quality software more rapidly. Agile is a spectrum. You can apply a version of Agile that works ideally to your team. Iterative development is the basis to continuous integration. As Donovan Brown put it, continuous integration is used to improve the productivity of your iterations. Continuously test changes as they are being implemented. Continuously verify functional and structural quality, and continuously have a deliverable product. Test-driven development is a developer-oriented process that can be used with Agile processes to ensure modernized quality assurance on your team. It guarantees test coverage by mandating that tests are created before features are implemented. Requirement gaps can be discovered by validating your feature implementation with these pre-written tests. There are many modern support tools that are helpful to create and manage tests that match your application and work environment. Code review is one of the most effective measures in preventing code errors and helps educate your team by seeing changes in your code base. Version control, like Git, Mercurial, SVN, or even PVCS, is critical. Version control provides the ability to compare your source files, identify any differences, and merge source changes in digestible chunks. It makes troubleshooting much easier, and you can directly see what, when, and where your changes were made. It streamlines keeping track of versioning between production, development, and QA. And of course, testing frameworks like MS Test, Appium, or Selenium that can be used to create and manage tests that match your application and work environment. But most of all, this all saves time, handles versioning for you, and will have your back when you need to know how something was done in the past. And of course, there's work management and tracking software like Azure DevOps or Jira or even Trello if that's what you want to use. Our development team now uses Azure DevOps to handle project management, and these kinds of tools allow you to collaborate more easily, manage schedules, track performance, and delegate tasks. We can synchronize these tools with our delivery pipeline to automatically build, test, stage, and deploy, and hopefully utilize it in the future to measure the health of our product. This management software can be used in conjunction with version control to automatically link task documentation to the associated code changes, so you have a complete picture and history of what work was done.
So, why do we test?
Why do we test?
What if we told you
It was actually
to save time?
So with modern testing practices, you will not only save time testing, you will save time developing. Testing effectively serves as a productivity multiplier for development.
Think of Agile testing practices as an investment that will return you much more than you put in by ensuring you continuously have high-quality, deliverable software by keeping technical debt to the minimum.
With continuously high-quality software, everything else will come as a bonus. End users, development, and stakeholders will all have the software quality they need to be satisfied.
By having high-quality testing practices, your testing should continuously keep up with development.
Continuous integration ultimately comes down to being able to iterate, test, deliver to end users faster. Each development iteration should be complete. You do not want your bugs to follow you into your next development iteration. A feature a developer is working on is not considered complete unless it's been fully tested and integrated. Complete development iterations provide exponential rewards. The faster you iterate and test, the faster you can continue to iterate and test. Avoid building up technical debt and instead continuously build upon a solid foundation of high quality. The biggest bottleneck for rapid development cycles is quality assurance lagging behind the pace of development. Without improving your development processes with continuous integration, it's impossible for quality assurance to keep up with the faster rate. Saving time with faster, complete development iterations will ultimately provide higher quality software.
By saving development time using modern Agile testing processes for rapid development, you really do get it all. You can find defects early. The faster you catch an issue, the less rework is involved in resolving it. Keeping technical debt to a minimum prevents growing unmanageable technical debt. With low technical debt, you'll always have a deliverable product at the end of each iteration of development. Continuously testing allows your unit and UI tests to stay up to date with your software as they're being continuously run with all the changes. You gain value. Lower technical debt will eliminate rework. You save time developing features and testing them when the phases are broken into smaller, complete iterations. You're making the most of your resources, keeping customers happy, preventing more customer-facing issues. You derive value every time you run your tests, so run them often. Flexibility. You reduce your risk, you reduce your downtime. The faster development and testing results in being more available to handle changing requirements or unexpected blockers. Quality of life for developers will improve through having more development time spent on features without being blocked by QA or resolving technical debt. The work your team can accomplish in an iteration, it's measured as velocity. You use this velocity to create a burn down that provides accurate delivery estimates even as new requirements are thrown into your project. And now you can say with confidence that for sure my product is always ready to show or deploy. My tests are in a good state and my customers are happy. Developers will now have immediate feedback for new features they implement through testing, providing continuous validation that requirements are being met. And this all ties into software quality. Let's just hammer in some of these key concepts. Rapid full development iterations improve software quality by enforcing consistently good design. You save time, improve quality. Use short, repeatable development cycles to incrementally build and maintain software to achieve this. Continuously review and validate both functional and non-functional requirements throughout these development cycles to maintain quality.
Remember, to have high software quality, we must begin by focusing on having high-quality development processes. Processes that can be used in synergy with continuous integration. The Agile processes that we are going to focus on can use test-driven development paradigm as a foundation for their approach. These Agile processes can also use unit tests written after code is completed, but for the highest quality software, we recommend considering test-driven development. So what is test-driven development? It's a software development process that relies on rapidly iterating through a very short development cycle, thus works well with continuous integration and other Agile methodologies. The process is test-driven, thus the primary mode of operation is to first author tests that fail, then code the features that make them work. You start by adding a failing set of tests that cover the features you're trying to build. Next, you write the code for the feature that works towards satisfying the test. Then you run the test to see how you've progressed. If they're still failing, continue repeating the last two steps until the tests pass. When you finally have passing tests, code review and refactor as needed to ensure that your new code meets code quality standards. If applicable, wrap it up with a round of additional system and integration tests to make sure that your new feature has not caused any unintended consequences elsewhere in the product. So what are the benefits to test-driven development? Well, you get to ensure high code coverage for your newly implemented features. Since you wrote the tests up front and wrote code to the tests, there should be little code that is not tested. It also shortens the programming feedback loop. Developers are writing tests, writing code, finding problems early, and resolving them before it becomes a rework level issue. This is highly compatible with other Agile methodologies. And since the tests are the developer's guide for implementing the feature, they become the spec. You have a fixed requirement that is easy to measure, and when the feature is complete, there are already passing tests providing concrete evidence that the feature meets requirements. If you are working with unit tests, work can be done in minimal chunks, one unit at a time. There are, of course, several things to consider when looking at test-driven development. There is a not insignificant amount of time spent before development has even begun. Requirements are translated into tests, which can feel like a substantial overhead. However, this should ultimately diminish the number of bugs and limit the amount of feature rework. Cannot stress that enough. It also is a newer methodology and is likely to be met with some resistance. Many developers are creatures of habit, and they may have difficulty adjusting to a significant change of development flow. In addition, it is very developer focused, so it typically requires intimate knowledge of your code's object model in order to write tests and specifications. It's not inherently useful to non-programming executives. This could lead to two effective sets of requirements, as one is strictly controlled by the developers and may not map one-to-one with the stakeholder specifications. And many of these considerations can be addressed using Agile methodologies that build upon the test-driven development paradigm.
So now we're going to go over a set of popular Agile development processes that can be used with the test-driven development paradigm. These processes can be used individually or even combined with one another. They all have good ideas that can be taken advantage of for your software development to ensure the highest quality software. Remember, Agile is a spectrum, and different components of Agile processes can be catered to your team's specific goals and missions. So we're going to start with behavior-driven development. It's a process that doesn't deviate much from the test-driven development paradigm, other than making the test more behavioral focused and business readable. This is done to include non-programming executives and other stakeholders within a test-driven development process. Behavior-driven software development uses domain-specific language to describe the desired behavior of features. The toughest part of behavior-driven development is writing the tests. It is almost like a set of best practices for writing your tests.
Next on the list is feature-driven development. Feature-driven development is a pragmatic client and architecture-focused software process. It uses something called Agile modeling to determine what the clients or project stakeholders actually desire. We could probably go into a lot of detail about how the modeling concept works, but the gist of feature-driven development is that it has lists of potential features that are compiled in a format of action result object, which is sort of like a super trimmed down user story format. These features are then mapped and scheduled based on complexity and value to the customer, and then each feature is assigned, designed, and built by a feature owner.
Lean development. Lean software development was adapted from the Toyota production system of manufacturing. Toyota benefited from implementing this manufacturing system by not only increasing their productivity, but by becoming one of the world's most reliable auto manufacturers. The same system that made Toyota so successful was brought into software development to provide increased productivity and quality. The key focus of lean software development is to eliminate all waste. Focus only on what adds value. No rework. Enable as much capacity for change in your system by making decisions as late as you possibly can, but then quickly following through with them. Think big, act small, fail fast, learn rapidly.
And of course, no list of Agile development methods would be complete without mentioning extreme programming. At its simplest, the goal of extreme programming is to produce higher quality software by using a mix of popular Agile methodologies that improve the general quality of life for developers. The methodology takes its name from the idea that perceived beneficial elements of traditional software development practices should be taken to the extreme level. So for any individual piece of software engineering that is beneficial, extreme programming seeks to find its most valuable point and exploit it to its maximum in pursuit of efficiency. It thrives on reducing the programming feedback loop to minimize the time not spent coding, and is notable for listening to customers for direct feedback in order to quickly adjust to changing conditions. Extreme programming's take on testing is particularly relevant to test-driven development. After all, if a few test cases can eliminate a few flaws, then lots of tests must be able to eliminate lots of flaws. Unit tests for every unit of code are highly encouraged, and regular or daily acceptance and integration testing is the best way to be able to continuously improve the software. Since the testing is so thorough and the feedback loop is so small, this methodology thrives on small, frequent releases. Code continuously, test continuously, release continuously. Seems like a perfect fit for continuous integration.
I agree. So Scrum, it's almost a superset of extreme programming. Scrum is also done in iterations, sprints, usually 2 to 4 weeks, and they utilize continuous integration. Feature implementation in Scrum is done through user stories. And compared to extreme programming, Scrum has a distinct focus on changing the way meetings are done. A sprint planning happens at the start of each sprint and is used to establish exactly what work and effort needs to be accomplished to deliver the sprint goal. Daily stand-up then happens daily throughout the sprint. It should never be more than 10 minutes. It is nothing more than a quick progress check and opportunity to address blockers. Now, sprint review happens at the end of a sprint. In sprint review, the team demos what they have accomplished during the sprint. This could be to management, developers, and stakeholders. The sprint retro meeting is the last thing you do in a sprint. Here, the team discusses the successes and failures from the sprint. How well did they achieve their goal for the sprint? What could be done better? Always keep improving your processes.
User stories are a tool common for many Agile software development practices, and we've talked about them a bit, but are especially fundamental in Scrum.
They are used to capture a description of a software feature into a small and manageable work item, making it easier to ensure quality as you go for each part of the software. These focused work items allow you to write detailed test cases. In a user story, you should describe the requirement using language that is easy to understand. Describe who the user is that will benefit from the functionality. Describe what functionality the user is looking for. Describe why the user wants the functionality to better ensure that functionality is what the user expects. User stories should always include acceptance criteria. This dictates that work must be accomplished for the requirement to be seen as done or accepted. Acceptance criteria is a solid foundation for your test cases. User stories can be estimated in hours or story points. Story points help your team relate user stories to one another when the hours could vary. Story points are agreed upon values that are unique to each team. Story points could take a different amount of hours to be done depending on the individual, but the weighting will stay consistent between the actual user stories. And they're also used to help measure velocity, so you can come up with a burn down.
So now that we've flown through so many popular Agile development methodologies, it seems about time that we brought the discussion back around to testing methodologies. In this section, we're digging into some pretty broad terms that you've probably heard before: Whitebox and Blackbox testing. What do they mean, and when is each appropriate?
In Whitebox testing, the internals are fully known. This can be seen as testing through the perspective of a developer. A Whitebox tester has full knowledge of the internal workings and structure of the code, and the test will be written accordingly. This is the most intricate form of testing, where individual units of code and code paths are tested. It is important to design test data for Whitebox testing according to your testing parameters.
And Blackbox testing is very much the opposite of Whitebox. In Blackbox testing, the internals are not known to the tester. Your interface to the software is intended to very much be the same as the interface to the user. You test in a black box environment and must be based on the external output of the code, not the internal behaviors that would be known in a Whitebox test. This means that you are testing the fully integrated product. These kinds of tests are getting as close to the real user experience as you can get, but are also frequently the hardest to write. Black box tests would be the worst place to try to test algorithms, for instance. However, since the tests are on the fully integrated product, that means that they can be written by developers, testers, or users alike. You might also hear black box referred to as closed box tests. They're largely the same term for the same thing.
So there's also a third kind of testing. Greybox testing is a middle ground option between white and black box testing. In Greybox testing, the internals relevant to testing are known. You're testing as a user with access to the internals of the system, and it can work pretty well with APIs.
Largely in our Visual Studio testing, Greybox is where we have to live because they are testing the integrated product, but we're able to provide some externals so that they have a better understanding of what is happening under the hood. So how do unit tests fit into this? Well, unit tests are designed to test individual units of code, so having access to those code units is pretty understandably a requirement. Unit tests are typically written as whitebox tests. Given that a close knowledge of code units is a necessity, unit tests should primarily be written by developers, but there are scenarios where having a QA team write unit tests makes sense too. You might actually consider writing unit tests in a black box scenario if the code you're testing is for a critical API. Since you have an exposed interface or contract, you still have what you need in order to build a unit test, just without quite the same tight coupling. The purpose of unit tests are to test individual small pieces of a much larger system. As such, they're not a complete requirements validation test, and instead check your code for logical errors. They should also be able to run in isolation from one another, as the core dependency for the unit test is the unit of code that it's testing, not all of the other interfaces around that code. Given a particular input, does the output of this code unit have the right result? That's what I'm trying to answer with a unit test. The best part about unit tests is how easy they are to write and maintain. Your unit tests aren't hitting a broad area of product, so the number of things that can negatively impact your unit test should be limited to the direct piece of code that is intended to be tested. But even when your unit test breaks, you have a direct map to what broke the test. So there's a clear picture of where functionality changed that caused this issue, and empowers and/or requires the developer to remedy the problem immediately. This is a huge value. The time from finding the issue was super short, and it can be caught before initial check-in or on the first unit test after a build. As for how to write unit tests, that's definitely left up to your development team and practices. However, there are a number of unit test platforms or frameworks that are designed to let you focus on writing meaningful tests, not fussing around with even more overhead and complexity. InUnit is an idiomatic port of Java's JUnit to C# and brings along its 30 years of history. The original JUnit predates the .NET framework entirely. However, when considering InUnit, do consider that it does not integrate effortlessly inside of Visual Studio. Its interoperability shines outside of Visual Studio, and it does have reasonably fast performance. If you're looking for a test framework that's a little more modern in design, xunit.net is an excellent option. This test platform was authored by the same person that created InUnit v2, so they already had some experience in this particular area. Some of xUnit's key areas are the intuitiveness of its design and the robust test result breakdown into facts and theories. It's a little lacking in documentation, however, so getting it to do exactly what you want could be a challenge. When it comes to .NET unit tests, our recommendation would be to use Microsoft Test, MS Test, or known as the Visual Studio Unit Test Framework. While it's not the fastest of the three options, it's shipped right in the box with Visual Studio. So if VS is installed, you probably already have access to MS Test. This also means that you have very tight integration with Visual Studio, from automatic test detection in code to providing a toolbar showing your tests, last test results, the test time, that sort of thing. Unit test projects can be created from the new project dialog, and Synergy.net unit test projects are available as well. So all you need to do is create the project, add some references, add a test, and run it. You will get results right in your IDE, and you can also run these tests at the command line with the VS Test Runner. A notable limitation of MS Test is that it has slower performance and limited interoperability outside of Visual Studio. However, they're not significant enough detractors to stop our own teams from using this tool. Having the tool work right in VS is just way too good a benefit.
Integration testing. So with integration testing, you are now testing integrated code units. So individual code units are integrated together to test more complete functionality of your software. You can fully test specific requirements. You test features and requirements to ensure they are working the way they are intended. You can also test more non-functional requirements. It's typically implemented at the user level, Blackbox testing. Internal structure, the design, implementation is not used for any of these tests. It provides a user perspective through behavioral testing of features and requirements, and it can also be Greybox. Who should write integration tests? It's usually QA, but developers can too, especially for integration tests that don't combine the full system or use more smoke testing or API testing. Automation is a must to increase testing speed to enable continuous integration. Without automation, it is impossible to keep up with rapid development. Manual tests are not reliably repeatable. It opens up the chance of user error and other inconsistencies. Manual testing has a lower initial cost, but exponentially growing overhead. And there's different variants to integration testing, from combining just several code units, like I said, to fully integrating a system with test or real data. For example, smoke testing. It could be Greybox, where several units are combined to produce expected results. It just ensures that units of code work together. It's used by developers similar to unit tests to test for smaller changes for major flaws without needing to run a full array of automated functional test suites. It's used to catch glaring integration and behavioral issues. Then we also have system testing. It's a black box test of a completely integrated system with all units of code. It tests the functionality of the system as a whole, both functional and non-functional requirements. It also has some of the most resources necessary to maintain, but provides the most test coverage for specific features. It can be split into different testing suites that cover aspects of your system. Just make sure you're using test cases and data for faster performance and easier to read results. It also includes more negative testing. Instead of only checking for requirements, system testing also looks for failure cases. You're looking for new issues, regressions, and you also push the limits of performance and other non-functional requirements. Now, acceptance testing. This is a positive testing. You're ensuring the behavior is as it is expected. Black box testing of a completely integrated system looking specifically to verify the functional requirements that were set. Acceptance testing helps verify if your software is acceptable for delivery. It can be done with real production data to mimic the user experience. It can be done also by end users through alpha and beta testing. Now we have a lot of integration test platforms to choose from. I just chose some of the most popular ones. There are different options also depending on what type of system you plan to test. For example, Selenium. Selenium automates browsers and web-based administrative tasks. It is a #1 in the industry for web browser automation and is absolutely free. Then we have something like Coded UI. It comes with Visual Studio Enterprise. Just install the Coded UI test component. It works very well with WinForms and WPF applications. We have Postman. It's the leading API testing tool used by Microsoft, PayPal, Atlassian, Adobe. You can even use Postman to create automated tests to monitor your API for uptime, responsiveness, and correctness. Test Complete, it's a more versatile tool to automate UI tests across like desktop, mobile, and web apps. It provides the ability to write robust scripts or just record basic automation. It is our current solution for testing SDI in Visual Studio.
Yeah.
Appium provides native app automation. Appium aims to automate any mobile or desktop app from any language and any test framework, with full access to backend APIs and databases from the test code. Appium is created by the makers of Selenium, and it's also free, so it could be worth looking into.
And so I want to take a short moment to touch on and define regression testing, since we're here and have already discussed many different testing and process topics. Regression testing, by definition, exists to ensure that your software meets a very important quality standard. Your past user space bugs do not resurface and put egg on your face. Adding tests for all of the new work you do is fantastic, but make sure you take the time to add integration or unit level tests that can validate the problems that your users see. This will help prevent a regression of user impacting issues from ever making it out of your doors or server or whatever you have. You should also take the time to make sure that your new work and changes meet previous requirements. If your changes cannot be reconciled with past requirements, it's important that you verify that it's the right change to make or understand why the previous requirement existed and ultimately make a decision about which requirement gets to live on, and proactively communicate with the impacted parties. If you always run these tests before deploying to end users, and hopefully even more frequently than that, then the perception of your software quality will be much higher, in addition to actually being higher quality. And so it's fine for us to be up here talking at length about the value of improving process quality and discussing the different types of test and development methodologies, but how are we applying these things ourselves? The best answer that I can give is that we're still evolving our own processes, and none of the development methodologies are a silver bullet that can transform our development team overnight. On Tuesday, you got to listen to the extensive changes that Donovan and his team at Microsoft made in order to make themselves more agile. That was a painful process that required iteration, measurement, and cooperation at multiple levels of the organization. And you can imagine that they had even more challenges that he didn't touch on. We are starting to shift mindsets to allow process improvement, rapid iteration, and more frequent releases to gain higher acceptance in our organization. But we aren't doing it for the sake of change. After the first time that I was exposed to continuous integration processes, I knew that I wanted to have it in our organization. But until the DevOps mindset started to take hold at Microsoft, I wasn't sure how I wanted to make it work at Synergex. I could see the value of shortening the feedback loop and broadening unit testing and automating as much of the process as possible, but I did not know the best way to get started. And Azure DevOps finally gave me a cohesive tool set that could put all of that engagement and enthusiasm that I had to work. So Azure DevOps helps give structure to what I wanted to achieve and open the door to automating and managing processes in a way that I knew I could provide concrete evidence and value to my supervisors. By bringing source management, task management, build management, and tests all into one place, it was obvious that we had an opportunity to really revitalize some of our processes. That isn't to say that I have fully moved full stop onto Azure DevOps as a tool. Our source is still in SVN, not Git. Our builds still happen on premises on our own build servers. Our tests still run on premises in virtual machines, but the framework for integrating all of those pieces together is clear, present, and available. So we've been incrementally trying process modifications that implement some of the Azure DevOps functionality. Recently, our installation refresh project was able to center almost entirely within Azure DevOps. We planned features, handled version control, code review, and automated builds and tests all through Azure DevOps. This let us work really fast and efficiently through the part of the project that required the most growth, and I felt like it was a huge success for us. And when the rate of change slowed down, we integrated how those pieces would tie back into the rest of the product set, because not all of our products are built that way, and made sure that it could continue to fit our existing procedures. But that one experience will forever change how I perceive software process. I'm still hungry for process improvement and reaching ever higher levels of software quality, and I think it might be contagious.
Definitely is. The test repeatability project. So our QA team has undergone a test improvement project to improve our UI test automation repeatability for SDI and Visual Studio. Our main purpose for making our integration tests more reliable is to follow continuous integration by including them with our automated delivery pipeline as SDI changes are made. Our integration for Visual Studio has proven challenging to test repeatably due to the nature of UI testing combined with frequent third-party changes. We have to be able to quickly adapt to changes in Visual Studio, Microsoft, SDI, and our testing platform, Test Complete. In order to make the test more repeatable, we have focused on improving maintainability and reliability by redesigning from the ground up how we interact. We have established a functional library for automation tests that enforces correct behavior and reduces redundancy. No longer will there be code for the same behavior in multiple locations. This helps by increasing reliability by reducing the frequency of intermittent issues, also ensuring consistent behavior that the test conditions are being met sufficiently. It speeds up test writing, and it's easier to handle maintaining updates, as to fix everything that does a certain behavior, you only need to make a change in one location. We have also used this as an opportunity to begin practicing more of the modern Agile practices. We have incorporated iterative work increments as sprints into our project management. We use 2-week sprints. We are using Agile estimation methods such as user stories, story points, and velocity to plan our workload and provide estimates for delivery. We are using Azure DevOps for work tracking. It has proven a very useful tool in attaching documentation such as acceptance criteria to tasks that can be directly linked with their respective code changes. Azure DevOps helps provide an overview of what each team member is working on, making it easier to manage progress in daily team meetings. It helps us estimate an effective burn down to establish delivery dates. And we also get to use the Git flow model. Our team has started exclusively using Git for version control on our new development. We use the Git flow branching model with Git to separate our individual work items into short-lived feature branches that we merge into develop and then a master branch. Our goal is ultimately to continue to improve our process quality by moving towards a continuous integration environment.
Can you write unit tests for traditional Synergy code?
That is a great question, and it's one that I've been spending quite a lot of time thinking about. Writing tests for traditional Synergy is a bit of a challenge if you want to try to use the model that's presented in most unit test frameworks today. We don't really have attributing in traditional Synergy code that would let you do the definition of test methods the same way. And so I've been thinking about how we might be able to adapt some of those pieces to essentially build a test harness that could integrate maybe with the Visual Studio extension, but it doesn't exist today. I know that CU actually does quite a lot of traditional Synergy unit testing, but they actually drive it through test complete, and they run up full DBR instances in order to do it.
How often do you find you need to rewrite your UI integration tests?
Pretty much every time we used to run them, especially with before the test improvement project. We had a lot of redundant code and that would fail in different places, but now that we are moving into one spot, it's a lot easier to maintain.
Yeah, we've gotten to a place where the underlying core infrastructure of the UI tests is all one library, and it has its own set of unit tests. So our integration tests have their own unit tests. So this was actually a key for us because now when we get a Visual Studio update, we run the integration test, unit tests to see how the infrastructure has changed under us, and we just make a few changes, and the rest of our integration tests now run a lot better.
How many hours is a story point at Synergex?
It's currently about 2 to 3 hours per point, but that is completely different based on your team. Just the important part is making sure your whole team agrees on what the value of a point is. And you'll get better and better at estimating these as you go through iterations of development.
And if your team, clearly not everyone on your team is going to work at the exact same pace, so usually the value of your story points is based on the average of your whole team. So you see what everyone is capable of doing, and as each week progresses, you get a better picture of what your story points are worth.
Where would you incorporate integration testing in 2-week sprints?
Continuously.
Yeah.
Every time you commit, every time you build, you're doing integration testing.
How do you communicate/track unit test failures? Do you foster a culture of fix this immediately, or do they fall to the end of a project cycle?
So we have a process of run the unit tests before you check in your code, and if you have introduced failures, it's your responsibility to find out why they're failing. Rarely it will not be your code's fault, but since you're the one finding it, you do the initial investigation and figure out how to remedy it. Sometimes they make it through that process and they'll get to the build server, but our builds automatically run the unit tests before they ever get to a QA VM. So if the unit tests don't work in that environment, I get to know immediately, and then we set about fixing them.
That is it. Thank you.
Cool.
Thank you.
Thank you, everyone.